So a big part of this is we need to find the vectors that go to like the lowest point on the surface to advect these particles. And so what that pretty much is, that's called attribute gradient. And so what I do is I set up a velocity attribute to use for later. Now what you can normally do, I think it's broken this version because at work it's working. We have this py attribute here. That's the normal. No, I don't need that. So we're just doing v at py here. So we're just getting the height of the point pretty much and putting in a float attribute. So there is a polyframe which does this. I think this is a bug, but if you want an attribute gradient, it's really cool. You can go py, but it says invalid attribute py. So this should be working. It's not in in my version. It's not working. I have to update my version, but you can compute your attribute gradient on your points with this, and so that will build some vectors that I'll show you. So I'm going to skip a couple things here first. So I'm going to go VDB from polygons, and I'm going to pull in the y, the angle. This is a dot product of the surface, and so actually I will show a color of this. Ramp from attribute dot, and then I'm just going to pull up the contrast. So what you can see here is it's sort of like a mask. So I use this to multiply against the flow gradient, and so particles in the white areas will move faster than particles in the black areas. So that's to visualize that. So I'll go viz dot. Alright, so I create a surface. I get the point y attribute into a volume, the angle, and the velocity. Now these are all the fields, and so here's the attribute gradient. So I'm going to use a VDB analysis. I'm going to process the y field, so that's all the values, the y values in this field of the position. I'm just going to rename it to flow. I multiply, this is just adjusting the strength of the vectors, so I multiply it by a noise, and I can actually comment these out first, and then we'll put them back in. So I'm going to sample it onto the points for visualization purposes. So now you can see that we have these flow vectors. Right now they're pointing up, and so they're pointing to the highest direction of the point, as you can see. So if it's increasing here, it's going to go up this way because it's you have a slope that it's not as high. So as you can see, these vectors are flowing along the surface in a particular in the down direction, and so that is your attribute gradient. So all these vectors are they're going to carry to the lowest point on the surface. So let's put our adjustments back in, and you're going to see we've modified these vectors. So first we changed the direction, so they're going to flow down. They were flowing up. And then we're going to add in a bit of the surface velocity just to adjust it a little bit. So the next field that we need for the next step, which is the sim, is the closest point. And so if you have a surface, you can process the closest point, and you can have a field that this is basically a position field. So this returns the closest point on the surface to look up. And so that's pretty much your flow data for your sim. Thanks for watching. So we're going to go talk about the sim and the meshing in the next video.